Welcome to the VPI-Symposium, ladies and gentlemen. Unfortunately, we had to go for an online set. Let's put it that way, in terms of the knowledge base, and we wanted to make this a bit more homogeneous. We decided to go for this format together with the DAC Delivery Program. We also won over an additional partner from Austria. VPI Austria is also one of the hosts and accompanying this meeting. And we also look very much forward to provide information on the 4 topics that the agenda provides for and to discuss them. And we hope that after this meeting, everyone takes home additional knowledge on the DAC, Digital Automatic Coupler. The DAC will be the game changer, the enabler for the future of rail freight traffic. And we hope that we will increase everybody's knowledge on that. I'd also like to welcome my co-moderator. We are in close cooperation with the European DAC Delivery Program, set up a program here. And this is why I'd like to ask the program manager, Mr. Engelmann, to come to the stage and join me as a co-host. So we will be going through the different topics that you can see on the agenda in the sequence that you can see on the agenda. And we will also go through the questions. You might wonder where we got the questions from. We asked people to ask questions from the industry. We got a whole host of questions, a total of 200 actually. We clustered them, and today we will try to answer them in a meaningful fashion. I'm already asking you to bear with me if we cannot manage to answer some of the questions, but we will try to do our very best in order to live up to your expectations. After this meeting, we will also be providing you with the questions in written format and draft and provide a question and answer sheet on the website. So again, welcome, Mr. Jens Engelmann. The floor is all yours. Thank you very much, ladies and gentlemen, in the room, on the screens. We hope that there are many, many, many on the screens. Doing things at a European level. And this continuing dialogue is very important because we need this dialogue also with the sector so that we get your buy-in. And formats like this are just excellent to do this. So thank you very much from the European corner, so to speak. Now, what is this European corner? Heiko, could you perhaps show us this one slide? Because there's a lot of talk about EDDP. So in the past, there was a TIS, for example, but what is EDDP? EDDP is the European DAC Delivery Program, the DAC deployment program, so to speak, from constructing a DAC till employing it in the field. So the question is, are we only based in Central Europe? Is this a Central European thing? If you look at the map, the answer is no. We have 65 different players who are joining in, and as you can see from the European map, it's railway undertakings, it's wagon holders, it's the industry, it's scientific research institutions. So it's a very wide and broad-based program, and everyone who's working here is joining in. So this DAC for Europe is also supported very much by the whole of Europe. So thank you very much for having you. Probably it's only one of a series of meetings, but thank you for starting it. Okay. We will go right into the agenda and have a bit of a look at the political background. So for this purpose, I'd like Mr. Günther, Armin Günther from DB Cargo, to get on stage, who will lead us into the topic. Mr. Armin Günther is the program head for DAC at DB Cargo, and he will be giving us the first presentation. The floor is all yours, sir. Thank you very much for the welcome you most cordially, ladies and gentlemen, to my introductory presentation on DAC. And I would Coupling is nothing new, or coupling. We've had this in personnel traffic, and also the Scharfenberg design that has been around since 2013, so it's nothing new. But what we are trying to do now is nothing less but revolutionary, because we want to do the connection, the coupling with in one operation, one clack, as we call it. But that's not the end of it, and that's the beautiful thing about this, because mechanically speaking, such a digital automatic coupling is also more stable, so it can tolerate more forces, tensile forces, compression forces, etc., and that will also be very helpful. And I get back to that in a second. Now, this is also what and in the future, we also want to do an ergonomic decoupling, or even remotely controlled, done from the engine, the locomotive. So that might also be possible in the future. Okay, so this is the basis. There's all this coupling here. Starts with the customer in his yards, then via the sidings, etc. We do this very often. I think for DB Cargo we'll do 50,000 operations per day, and it's a cumbersome job. Now, this is why we want to simplify our entire coupling processes. So simplification is important, but also acceleration. We want to use less time for this. Now, before a train can start, can drive, we have to do numerous other things. For example, we have to see as to whether the wagon numbers are okay, the wagon orders are okay. We have to provide for rails kits. We have to attach a tail disc or rear signal. And you can see on the upper right-hand side, this is one of my hobby horses, actually. There are so many different options and variants of this in Europe, which is quite funny, or nuisance. We also have to make sure that the brakes are working, okay? This is why we do a brake test, where the colleague goes along the train, walks along the train, and checks the condition of the brake. With the wagon master in the next picture that does the technical examination, checking as to whether the train is fit for the run, and we might also be working with valves or controls, etc. Now, DAC provides us with possibilities here to automate at least part of that. So wagon identification is there, can just be read out just in one go. The wagon numbers are in the IT system, and you don't have to walk along the train and tick the boxes on a sheet of paper. Also, installing the rails kit or skid pan. It's a horror to install this, and I know that many people have given the question of how can we do without them quite a lot of thought. But there is light at the end of the tunnel, actually. So via actuators, for example, an electric pike brake might be doable, and then at least in some cases we might be able to do without those rails kits. Tail disc or rear signal, well, as I said, we want to relegate them to the museum, Perhaps you need some showcases for all the different versions, but we will not need them in the future. The train integrity is continuously monitored and is then also be forwarded to the infrastructure operator. Brake tests, same here. You can monitor them with sensors. You don't need a person going along the train all the time. You can test this without that remotely, for example, and then it's green, or if it's not green but yellow or red, of course you then have to check again. Also, the wagon examination, There are several components that can be handled via this. We also have research projects to that effect, also together with the Ministry of Transport, with camera bridges that we will be installing in big yards, for example, where we check the wagons from the outside and check the condition of the wagons. Now, all of that, we have to do all of that because we have to check the brakes. We don't want to start our car if we don't know that our brakes work. And, of course, Safety still comes first, of course, and I mean, rail freight traffic has been the safest mode of transport so far, and we want it to stay that way or even get even safer. But you can see we can gain a lot of time. A truck drives 200 kilometers in the time that it takes to form a train. And I believe that we can save time here by speeding up train formation and then putting the trains on the track, which will give us major benefits. In addition to this, what's also very important is that growth needs capacity. Capacity in train formation facilities, sidings, etc. Today, we have to say that many wagons are just standing around there for a long time. I wouldn't say that a train formation facility, I wouldn't go as far as saying that a train formation facility is just a parking lot, but, we want to get the trains out there as fast as possible and also to increase capacity. And we can increase capacity without building one additional track. And this is what I call smart capacity. Next level, level 3. That's a train run. Okay, so the train is on the track, but this doesn't get us to the end of the benefits of the DAC. Now, okay. What can you gain? What can the DAC give you while a train is running? First of all, I already mentioned it, the coupling has a higher mechanical strength than the screw coupling. So this gives us the possibility to drive a train in brake position P, as it is called. So we can be a bit faster than we do this for heavy freight trains. Faster than we do today. Also, a modern braking system could be introduced into freight train traffic, such as the EP brake, the electronically controlled pneumatic brake. That's a standard for passenger trains, but it's also possible for freight trains. So you can have longer and heavier trains at the same speed or even at a somewhat higher speed. And again, these are contributions to smart capacity. So without building any additional tracks, we manage to have more rail traffic on the track. Now you have tensor strength, compressor strength, high tolerability to those, and then I'll show you another thing that can help us to increase the capacity, so the number of loads. Distributed power. Now, what is that? It means that in the midst of the freight train, you have an engine or locomotive. Now you have sometimes two engines or locomotives at the start, at the head. But now you can do this in the middle, and those two locomotives can synchronize each other, and this gives you yet additional capacity for longer and heavier trains, even if you have steeper inclines, for example. Then again, the rear disc, I already mentioned this, we don't want to have this again, but one very important detail shall be mentioned here as well. This is also the preconditions for EDCS Level 3, so driving in a dynamic block space operation, which is an additional measure to create smart capacity. So with a smart train, without a digital train integrity, this might not be feasible, but we need this train integrity monitoring for the introduction of EDCS Level 3. And then safety, security, for example, derailment detection can also be introduced and thus make rail freight traffic even safer than it already is. I mean, we are already at the top. So higher speeds, shorter spaces between trains, longer trains, heavier trains, all of this increases the overall productivity and increases capacity without having to build anything. Okay, level 4. Now you're on your way to the client and to the destination, and of course you then also ask yourselves, what do these clients need? Now here several factors come in. For example, additional signs or signage. You know, you have the smartphone here, but it can be linked via IT systems providing specific information of the transported goods. They come in via sensors, telematics. You can monitor the location, temperature. Yes, you can do this today. I mean, our wagons are equipped with telematics devices. We do have this today, and of course, they have batteries. Data is being transmitted via radio. That's possible, but it's of course limited. Now, if you have continuous provision of power and a continuous data line, of course this gives you a completely different level of reliability. For these things, you might also have additional indicators or lighting for loading and unloading, for example. So things might have to be taken into consideration, like some levers, actuators. Sometimes you might need line. I mean, we're working in a 24/7 operation, so this might become relevant. Also, we can introduce interfaces to our customer systems. Another interesting thing is the monitoring of transported goods, for example, goods that are more likely to be stolen than others. So automatic alarms might be introduced, or a possibility to immediately call the police. I mean, this already exists. DB Schenker or other colleagues, already installed this. It's battery-powered, mind you, so it's slightly limited, but that would be a beautiful use case, opening up new fields for logistics purposes. And last but not least, all of this information helps us to know our wagons better. Now, how is it doing? Conditions-based maintenance might be introduced, and thus then again might lead to an increase in productivities. All of these are added values that the DAC can bring about. Now let me summarize. I tried to show that DAC is the basis for digitalization and automation in rail freight traffic. We need this. Without a DAC, we will not get there. But if we have it, we are well equipped for the logistic requirements as they are today and as they will be in the future. Networking, digitalization, etc. This is the basis. And this is why the DAC is an essential component for the growth that we want to see in digital freight traffic, and all market participants will benefit from that. And we are also, of course, making our contribution to the decarbonization targets of the politicians in Europe and Germany. I wouldn't say that this is just a small side effect. No, it's one of the major aims by getting freight traffic from the road on the rail. So thank you very much for your attention, ladies and gentlemen. And at the end, I would just like to ask everyone to really chime in to participate in this historic innovation. We have the opportunity now to make it happen. So please contribute. Every idea is valuable. Every contribution is valuable. Join in the EDDP if you haven't joined it already, or get in contact with us. Thank you very much for your attention. Thank you very much, Mr. Günther, Dr. Günther, for these very illustrative use cases. And I think he's speaking on behalf of all of us. I can say, yes, we do. Yes, we want that. And I also believe that it's an essential step for the future of rail freight traffic. But the question is, how do we get there? Because it will take a lot of effort. It will take a lot of effort, and we will be looking at what it takes with the 4 items on the agenda. The good thing is that some effort has already been made, so we will get an idea of what the progress looks like that has already been made, and then we will answer the questions. So we go into the first topic of this technology, and I'd like Mr. Fabian Wacek from DBAG to come to the rostrum, the head of the DAC4U program, who will give us an introduction into the technology. Mr. Watzek, the floor is all yours.
Thank you very much for the kind introduction. Now, I would like to use the opportunity and start my presentation with a short film. Now, we've done a lot of work, and my colleague briefly spoke about what has already been done. And he's also pointed at the range of tasks that need to be fulfilled, the tests to be performed, etc. And by way of the upcoming film, I would like to try and summarize, all the things that have been done over the past couple of months, etc. So, can we please start the film? Here we go. DAC for Europe. Well, as you can see in this film, we've only just started working on the DAC, and we are fully forging ahead. We're now in the testing process. We're not only performing individual tests, but I would like to show you on the next few slides what we've done over the past couple of months and what we're going to be doing in the more recent, in the more closer future. So let's take a look at what we've achieved last year. Where are we coming from? Now, last year was an extremely busy year in terms of system tests. We had to try out a lot of new things and, verify the fitness for practical use. We did climate chamber tests with our colleagues in Minden to, verify the proper functioning. We conducted tests at 25 degrees, minus 25 degrees, thick layers of ice. In February, in addition to everything that worked out well, we found that there was a certain need for improvement. So, a lot of rectification had to be done together with the OEMs. We then said, okay, we're going to go ahead with it, and we are even prepared to extend the test phase, which we did at the Görlitz test site. We did very detailed tests there. And, throughout March, April, and May, we continued the test activities, looking at each and every system, and we did our very best, to test every single system to come up with a highly consistent database, which would allow us to make progress in the decision-making process. We were the ones, providing information in addition to other parties. and that's why we decided to continue these tests up until June of 2021. And as I said, we tested each and every system in a very detailed fashion. We did so repeatedly to try and find what are the capacity limits of these systems we're talking about. In the middle of the year, we decided, and we heard that in the previous presentation, that it's one thing, knowing how the coupler works from a technical point of view. But in addition to that, we needed to find out whether it is fit for a practice, Does it work in reality? Can we provide evidence that the system works in real life? And that's why we started parallel works, and I would like to thank the colleagues who were involved in that. So in parallel to the tests going on at the test sites, we started building the demonstrator. We prepared data for EDDP, and in parallel to the tests, we, started doing initial field tests. At a shunting station, we started using the system to find out what is working, what is not working, where do we need to improve the things. And after a lot of workshops with EDTP, we decided to go in favor of the Scharfenberg design. That's a decision that was obtained in September, and from then onwards we were able to fully focus on the Scharfenberg design. We then started equipping more wagons gradually. We went to different operating sites because it's quite clear that it's not good enough to only look at one shunting station, Mannheim or Ludwigshafen, because there you will certainly encounter specific problems, but you will also see other problems at other shunting stations, shunting facilities, and that's why we decided to roll out the practical tests at other shunting stations too. Because, where's the point in, knowing a lot about, operations in Germany when you don't know what the situation outside of Germany is? Because after all, this is going to be a truly European solution. It's not something that we want to fine-tune in our shunting facilities and our stations, but we want to be able to roll it out Europe-wide, and this is the phase that we are in right now. So at the beginning of February, the demonstrator train will be deployed in Austria at different test sites, where we will do more or less the same program to find out how does the DAC work, in the interplay with the technical conditions on the ground. We're also going to go to Switzerland and try out things there. And after that, when it comes to 2022, and this is the specific challenge, we are going to go to other countries too. We have gotten in touch with the colleagues from the Czech Republic, from Poland, from France, from Sweden. And this goes to show that we intend to, roll out this system and advertise the system in other European countries, and to gradually find out what is working, what is not working, where are problems that remain, and where can we still improve things. And it's quite clear that a number of things can still be improved if we are to get to a situation where everything works 100%. We're pretty close. A lot of things are working very well already, but a number of obstacles remain that need to be overcome. Now, let me also tell you, and I'm happy that the Federal Ministry of Transport has joined the effort, and they asked me to tell you that because now the final reports are available. A lot of measurement data are available. All of this can be found on the BMVI website, and you can find the respective link on the Ministry's website. I trust that you can find it, online if you do a Google search, etc. So this is a central repository which gives you all the findings from phase 1 available to everybody. I'm very happy that we've managed to put this together. It's a huge package of documents, facts and figures, and as I said, we have put this together to benefit from it, in terms of practical applications. And we hope that by the end of 2022, we'll be able to come up with an even bigger data repository, which will focus on the use of and the application of DAC in real life. Thank you very much. Thank you, Mr. Watzek. Why don't you join me on the panel to do a deep dive? Let me also tell you that the development of this specific project is breathtaking in terms of its speed, especially when it comes to railway applications. I once, spoke about it in an interview. It's almost at the speed of light. 2 years ago, a representative of the ministry told us that the demonstrator would be available soon. Last year's symposium took a look at the workshop, and now we are one step further. We've selected the coupler. We've started Europe-wide tests, which, means that we are very well underway. Okay, that's it from me. I suggest that we move on to the questions that we've received from the audience. I'd like to invite two more experts, Stefan Hagenlocher from a consultancy from HWH. And, he's worked a lot on behalf of the Federal Ministry of Transport. And I would also like to invite another expert, Oliver Behrens from GATX. Mr. Behrens has been active in the EDDP project. Oliver, it's great to have you on the panel. Welcome. Let me also tell you, ladies and gentlemen, that all the panelists have been tested and have received their booster jabs, so we're complying with all the relevant COVID hygiene rules. Jens, would you like to start? I might as well, start. Now, there were questions regarding the reliability and the tests. And if I may, I'd like to hand over to Mr. Lenners from VDV, who will ask the first question. Mr. Lenners, you have the floor. Now, hopefully everybody can hear me, says Mr. Lenners. Now, the questions submitted by VDV, they were submitted before the presentation. I'd like to read it out. Now, the decision at European level was in favor of the SHAKU, the Schaffenberg coupler. What have initial results been like, and how do you secure, in the context of the DAC for Europe project, that teething troubles can be excluded? Thank you very much for that question. And I can actually see where you're coming from and why you would be asking this kind of question. Now let me answer as follows. We've done approximately 2,000 tests at the Görlitz test site, and therefore we are pretty certain that the system comes with the required capacity and performance levels. So it's a very promising system, and we have high hopes that it will live up to our requirements. Now, of course, we were not the only ones carrying out tests. The Swedish colleagues did so too. There's a number of test consortia doing tests, and we will continue testing throughout the entire year 2022, which is very much the purpose of these tests campaign, to be able to say that we've tried out everything and we are certain that the system works, and, we now know what is still missing. Thank you very much. I'd like to hand over to the Austrian colleagues. There's also a number of questions regarding the timeline and reliability. Thank you very much, Malte. Here's a brief remark from me. I'd first like to thank the organizers to be able to participate in this splendid event, because we have received a number of questions from Austria on this specific topic. The format and the agenda is very well suited to fill the knowledge gaps and to answer any outstanding questions. Now, here comes a question. Mr. Bartek, you spoke about the envisaged timeline for the operating tests. Now, could you please try and specify the timeline? Where will the demonstrator train be applied, and when will that happen? Happy to do that, says the panelist. Now, what are we going to do with the demonstrator train? Over the next 2 months or so, we're going to do the tests in Switzerland and Austria. And there will also be another test phase in Germany, where we will do a number of rectifications together with the the OEMs, make a number of conversions, still a number of improvements to be done. Also, and we're currently trying to figure out how that can work, we are intending to go to the Eastern European countries for 4 weeks. Hopefully, there'll also be a 4-week stint in France, to the west from Germany. And this is where we intend to gather additional experience. In parallel to that, and Stefan is much more closely involved in that, what's happening in parallel and afterwards, I can tell you that we've already started talks to make sure that come 2023, we're going to do more tests and continue the current tests together with other test consortia, also in other European countries. Why? Well, because we want to be able to find out more about, the properties of the commercial demonstrator. And this will be about fine-tuning the system. Hannes, would you like to answer? Or to answer this question, rather? Now, when it comes to the coupling head, there was a question in Austria. Why did you not focus on system compatibility with systems that are already in use? So, did you look at the question of system compatibility when you selected the coupling head? Well, for the current tests, and this is sort of the underlying rationale, we said that compatibility should not be a criteria that should be at the top of the agenda. We want to come up with the most powerful, the most mature system to launch on the market to gain the biggest possible benefit. Now, of course, we spoke about the screw coupler compatibility, and if you think of the future, sooner or later these screw couplers won't be used anymore. For the engines, the locomotives, we need hybrid couplers, which are capable of, accommodating both types of couplers. For the wagons, that's not so important. And if you, take a look at Eastern Europe, we've also tested the SA3 system, which is not as powerful as we would have needed it to be. We put it through the same tests as the other systems, and that's why the EDTP decided against it. And, when it comes to eastward journeys, it's not so much, an issue of, coupling wagons. It's more about the track gauge that poses a problem. And, you have to do transshipment anyway. And that's why I think there's a limited use of coupler compatibility eastward. And that's why we did not focus on compatibility, so strongly. I'd like to come in here briefly. From the point of view of EDTP, we focused on that aspect, of course, and we aligned that at the program board level. So do we need, SA3 compatibility, the Russian system, or are there perhaps, more prevalent aspects to be borne in mind? Perhaps it's not even necessary to accommodate the Eastern European systems. At the IC times, this was different, but, there's no point in having SA3 compatibility because the track gauge won't change. And that's why we said, if the system were not up to scratch, we don't need it, and that's why we decided against system compatibility. Okay, thank you very much. Let's move on to the coupling head and reliability questions. We've received a question from the Alliance Pro Schiene. So what about, the system reliability? There's a number of questions about reliability from the Pro Rail Alliance. We are familiar with the Scharfenberg coupler from passenger train traffic, where you only have two, components to be coupled and decoupled. And even that doesn't always work properly in passenger trains. So when it comes to freight trains, there's a number of coupling operations to be performed. Hence, you need a higher reliability. So what about the reliability of the system? Now, reliability is certainly a question that we talked about. And I can tell you that, at the level of the EDTP, we're still talking about that. We are analyzing everything. When it comes to the mechanical part, we're pretty hopeful. We've never had any major problems. It's working very well and in a very reliable fashion. More difficult situation when it comes to power lines and data lines. And this is where the bulk of our analysis work is currently happening, in terms of reliability. And the clear focus is on these things to be tested, and it's quite clear that a system can only be introduced if, reliability is given, if the system is sufficiently reliable. Okay, thank you very much. Let's move on to, certification questions. Before we do that, a number of questions of cornering and tensile force and weight-related questions. Now, VPI Austria asked, how many wagons can be coupled. The question's already been answered, says the representative from Austria. The coupling is stronger, mechanically speaking. We've already heard that. The question more specifically was about, the traction force of the train. What traction forces are we talking about, and what is the added benefit of using the DAC? Well, the maximum traction power wasn't a test criteria per se, but there was a list of specifications which all manufacturers complied with. 1,000 kilonewton tensile force, and the same for compressive force, which was complied with by all manufacturers. This was verified. The manufacturers provided documents to that effect. So we think, we're confident to say that, there is a 100% increase of the traction force compared to the screw coupler. So this will allow for, working with heavier trains. And then there was a question of the radius. How far can we go down? What is the smallest possible radius? That was a question by VCI. Now, always an important question. And it's interesting to see where the differences are between the two couplers. GATX, thankfully, provided us with 2 rail tankers, and they come with a pretty, difficult dimensions, and it's possible to drive them on a 75-meter track bend, and we can also do coupling and decoupling. This wouldn't be possible with a screw coupler, and we can do it with the DAC. That's good news. A last question from the technical category. What about weight-related issues? Well, right from the outset, it was important to get weight neutrality. First, because we don't want to suffer any disadvantages if we equip the wagons with a digital automatic coupler. And it's also important against the backdrop of certification questions. If there were differences regarding the maximum admissible weight, the brake calculations, the brake parameters would no longer be valid, and that would have been a big problem. So we wanted to go for a weight neutrality right from the outset, including the electronic parts like the buffer battery. We're talking about the 500 kilo tolerance, which means that the brake parameters won't really change. Thank you very much. Let's move on to the conversion-related questions, which is also to do with the technical questions. The Association of Chemical Companies has sent us a number of questions, and I'd like to ask you to read out the questions. Happy to do that, and it's great to see that our customers too are interested in these topics. And I'm happy to read out the question of VCI, the Chemical Industry Association. Is there an obligation to make new build wagons DAC ready? If no, should this be discussed? Well, happy to answer that. There is no such requirement for the time being. That's the answer I can give you now. The VP3 of EDGP, Workshop 3, which deals with migration, is of course focusing on questions like this, but ultimately the point is that the European Railway Authority will introduce these deadlines into their rules and regulations. They will certainly be guided by the EDGP working group and follow their recommendations. Right now we are seeing a trend that the migration scenario will happen between 2026 and 2030. So, it'll be around 2030 or so, which will be the cutoff date when the wagons will have to come, DAC ready to obtain certification. What about the wagons that cannot be converted? Well, those wagons that simply cannot be converted, well, there will be a transition period in which they can keep running. We will then have to verify whether they cannot be converted for technical reasons. If that were to be the case, it will be possible to use them until the end of the migration period. After that, this won't be possible in terms of standard operations anymore. Another question from the Pro-Rail Alliance on the conversion question. Now, that's a legal question. To what extent are there EU regulations on the new build of wagons, and do they allow for a quick fitting of the digital automatic coupler, DAC? Well, legally speaking, we are pretty much advanced already. There's DIN 12663 Part 2, which specifies the technical requirements, such as, technical parameters, 2,000 kilonewton as regards to compressive forces, etc. This is not a new requirement, mind you. And this was also one of the preconditions in the EDTP working package, to be guided by the existing technical specifications. Over the past 10 years, freight wagons have come with, standardized dimensions, and they are fit for an SA3 coupler, which was envisaged at the time. And we were guided by these parameters in our work, and this was the basis that we proceeded from, to be able to convert the biggest part of the wagon fleet. So, most of the wagons will be able to withstand the compressive forces that are required. Now, TSI will define DAC as a compatibility component so as to make sure that everything is legally watertight. Before TSI WAC will take effect, we will have a technical document from the ERI. This technical document will also be informed by the results of the working group number 1 of EDTP, and certainly the technical requirements and parameters will be included there, so that it will be possible, to start operations from day one. Now, from the point of view of the EDTP, I'd like to talk about the question of, conversion, also for the audience out there, for all those following us on the internet. So, when do we have to do the conversions? And, from the point of view of European rail freight traffic, it wouldn't be possible to have a conversion requirement without having the product. That would be a very sad situation. Or imagine there is the obligation and you don't know how to fund it. And that's why we said we're going to do it when the whole package is ready, when all parameters are available, once the technical problems have been sorted out, once we know what the wagons we'll be using, from when we'll be using them, how migration will take place. Once all these questions have been sorted out, we're going to talk about the mandatory, conversion requirements. And, of course, we're also going to have to talk about funding. Because, if you want to use funding, there has to be a European solution. And all of this needs to be aligned, all across Europe. We don't want to, have a piecemeal approach. That wouldn't make any sense. Now, what are we talking about more specifically, in terms of conversion? There's a question from VCI and from the Pro-Rail Alliance. Perhaps you would like to read out questions 502, 503. Now, this is a question from VCI. What is the share of cargo wagons which will have to be removed from traffic because they can't be converted because they're too old? And what is the assumed share of freight wagons which don't need to be converted because they come DAC ready from the start? Thank you very much for this question. Well, the exact volumes are currently discussed in Work Package 3 at the level of the EDTP, and we will know more in a couple of months from now. What we do, we always look at the wagons of EVV, 560,000 freight wagons approximately. Now, we know that the average age is 30 years, pretty old. That's the average age for European freight wagons. So it's fair to assume that many of these wagons won't be equipped with the DAC because the holders will decide to, to let go of them instead of equipping them with a rather costly technology. We also know that approximately 8,000 to 10,000 freight wagons are put on the rails every year. And once TSI WAG becomes mandatory, once the DAC is mandatory, they will have to come DAC ready once they are launched on the market. What about the total volume? How many wagons are we talking about? Well, of course, the numbers vary. The initial basis is the 560,000 freight wagons from AVV. And depending on what the wagon holders decide themselves, what will be the age limit to do this kind of investment, it's fair to assume that there's going to be between 350 and 450,000 freight wagons approximately. But, please bear with us that this is, a figure that is still being worked on, and we still have to work out the final figure together with the wagon keepers. One more question in terms of conversion from the Pro-Rail Alliance, and it's to do with the fact that, not all wagons are capable of that.
Yeah, we heard there are some wagons who have not been equipped for DACs as a standard. Now, older wagons that cannot provide for that, and where force can only be introduced via the buffers from the outside, how can they be retrofitted? Can they be retrofitted at all? What would be the additional cost, and would it make any sense at all? I mean, wagons which cannot be retrofitted or converted cannot be retrofitted and converted. That's the way it is. Now, the question is, how many are there? I'm not sure, really. As I already explained, I assume that the usual wagon park has UC1-1. And if this is the case, of course, the structure is given. And then, of course, you have to see as to whether the compression force can be introduced via the so-called connection C instead of the buffers. Now, how much will have to be spent for the retrofit or the conversion? I don't know, really. Please bear with me. I can't give you a lump sum here because every wagon holder would have to assess this for himself and then also decide whether it's still worth it to examine the wagons as to whether to be converted depending on their fleet and as to whether they want to spend the money to do this. If they cannot be retrofitted or if it's not economically feasible to do so, they just have to be idled or used for other purposes. Now, we as wagon holders, we always like to look from the perspective of the wagon, but the center buffer couple also has to be looked at. And so the first question on the traction comes from the VDV. Now, which adaptations have to be made with regard to the traction unit, the traction vehicle, and what is the current state when it comes to automation and automation equipment? I mean, yes, we're only talking about a DAC, but talking about the DAC, we're talking about an overall system. So what we need for the engine and the wagons are data lines and power lines. Talking about the wagon, we need an accumulator, we need a power converter, which transforms high voltage to 48V for the wagon. We need power management systems on the wagons, for example, that, can control power demand. If too much supply is available, we need a communication hub or node that bundles all the communication. Also, they have to prepare the locomotive, or the engine has to prepare in such a way, or has to be outfitted in such a way that it provides sufficient power and that it also carries a hub or node, which is just a small module, actually. And then, and this is probably the most complex part, there has to be a possibility of interaction between the train driver and the train, so a man-machine interface, so to speak. And I reckon that for existing engines, this can be implemented or will most probably be implemented via a tablet. But when we're talking about new engines, of course, we have to install this and integrate this right from the start, so that, for example, pneumatic brakes and so on and so forth can all be displayed. And who is doing this? Now, the specification, the technical specification of the energy and communication systems includes the entire hardware. And this is being done in the EDDP, the Work Package 1. So there's a whole host of experts from industry, from the wagon holders, from the railway undertakings, etc., from the different countries. The development of the further automation technology, for example, having a standardized automatic brake test or a standardized integrated train integrity test, for example, this is pre-specified for EDTP, but it is to develop up to a prototype in the Shift to Rail project. Thank you very much. Question from France. We have questions on the traction units, and I mean, and we are so international that we have the French questions asked by an Austrian. So I hope you bear with me if I do this in German. Okay. Two questions from SNCF. Well, there's a bit of complexity. I mean, the connection to the traction unit. So, in how far have the producers of engines already been included in the DAC efforts? Question number one. And question number two on this matter. In Europe, apart from the demonstrator train, are there already engines that are equipped with DAC or converted to DAC? And question number one, yes, of course, the engine manufacturers are just as important as the engine holders. Without that, we cannot have DAC. Siemens, for example, just to give you one example, is active everywhere. Alstom Bombardier has been in it right from the start. So the engine producers have been there right from the start. And Fabienne, second part of the question, do you want to take it? Happy to. Essential. It's an absolutely essential question. Well, where is the DAC already being used? Now, luckily enough, with the approach that we used for the demonstrator train, namely being a consortium, so to speak, a syndicate, which also includes DB Cargo, and DB Cargo has already been using an automated coupling. This is a Schaffenberg coupling. There are also prototypes of a hybrid coupling and prototypes for how this can be implemented with the engine. And they're also using this with the wagon, for example. But and Bruno mentioned this without but they're using this without the D part, only with the A part. But we already gained considerable experience with the A part only. Okay, engine construction. You know, it sounds like, okay, this is something we will add on or do as well. But it's not entirely trivial. Mind you, there are some old engines still running in Europe, for example. So what we're doing at the moment is cataloging the types that are still out there. And when it comes to those older engine types, we still have to see who are we talking to, right? And this is fairly tricky, actually, so let's not beat the bush about this, but we hope we will solve it. Okay, question number 6. Question 606. Lennart, coming from your company. Well, we're all talking a lot about the trains and the track, and we might be forgetting about the last mile. Now, what about the interplay between DAC for wagons and the automatic shunting couples being used for engines at the moment? Well, this was also part of the EDDP discussions in this technological package. So technologically speaking, everything is possible. If we do a hybrid coupler, for example, that can not only go for screw couples or DAC, but other types, automatic coupling, makes the coupling more complex, makes it heavier, makes it more failure prone. It's basically possible in principle. There are no prototypes yet. If the railway undertakings would like to have that, we might go for it, but currently it's not being developed. The traction units, also on traction units from the question from the SNCF demonstrator. Also, demonstrator trains, DAC, engine, wagon, etc. I think this refers a bit to what is being done in Switzerland. Very brief. As Fabian Watzek already mentioned, in Switzerland we have 3 traction units with a hybrid or engine types with a hybrid coupling, so automatic coupling without data and power lines, mind you. Okay, I think the engines will stay with us for a while, but it can be solved, but not as many as wagons, but level number 5. Level 4, level 5. Some people might remember that we started with the claim to do 4, and then we go to level 5 with fully automatic coupling. Now, this is no longer that clear. Fabian, where are we? Perhaps the VDB might ask its own question again very openly and honestly. The current migration plans provide for DAC of level 4. This is data transformation automatic coupling. What do you think? What is the perspective for DAC 5, which would also provide and facilitate automatic decoupling? Because it's not only about coupling, it's also about decoupling, isn't it, in the last analysis? Okay, very straightforward. The requirements with regard to the prototypes is upgradability, so to speak. So all prototypes that we are using are able to go for DAC 4 and 5. But we are testing this, but we have to differentiate quite clearly. What does DAC 5 really mean? It's not only about the technological things, so the things that are happening in the coupling head. We are testing that. We're trying this. There are alternative systems, electric systems, pneumatic systems, etc. But the decisive point when it comes to DAC 5 is that you do not only want to do things at the wagon level, but centrally controlled. And this brings in completely different aspects. So, again, there's a lot of effort required, but the technological feasibility, we are pretty relaxed about this, and we are already testing things. Okay, Stefan, a brief comment on the discussion that we are currently having on 4-5, etc. I think it very much depends on the operational modes at the hump, etc., in the shunting yards, etc., how things can be harmonized there. It's not only the coupling, it's a bit more complex, isn't it? Yeah, I mean, type 4 only means that coupling is done automatically and decoupling is done manually. We have introduced a somewhat interim category, 4-5. So the coupling already includes an electronic motor, and you just push a button at the side of the wagon box and you can decoupling it. But this is not a remotely controlled decoupling, but a manual operation, a manual exercise. Type number 5, automation level number 5, is of course the icing on the cake, because it means that you can decouple it remotely, and there's more effort is required here, because it means that you have to be able to remotely control brake valves. You have a parking brake that is remotely controlled. In the shunting yards, with regard to the operations in the shunting yards, you have to know when the coupling and decoupling is supposed to happen. So you have to have harmonization there. So these are things that are not impossible when it comes to technological feasibility, but the question is as to whether we will be able to do it within the next 2 or 3 years. So this is a major effort. Let's make no mistake. Yeah, but we're working at it, aren't we? So cluster. In this cluster, I would like to discuss 2 things: the data and energy transmission and the explosion protection proofness. I would like to hand over to the representative of the NEE. Perhaps you can summarize your 2 questions. Actually, it was just 1 question, was it? Okay. So is data transmission also provided via radio? Can we cluster this? This is about data transmission via radio and the voltage and power supply. Okay, let me say something on data transmission or data communication. Basically speaking, this would be it's a subject matter for an entire seminar. I try to summarize it in 2 minutes. Now, basically, when it comes to the intra-train communication, an essential part of that is that you can have an integrity examination of the train every second. There are 3 basic possibilities to transmit this data. You can do this via mobile transmission, via cloud. You can do this via radio, or you can do this via data line. Now, and all the experts, looking at all the different pros and cons of those 3 possibilities, said that if you have a data line on the train in order for power supply, for example, you can add a data line to it, because it's the most secure way to also run safety-relevant applications. Let me give you an example. When it comes to radio-based inter-train communication, when you have train initialization and you have the wagon order and there are 20 trains next to each other and they all send out their radio signals, those wagons and those trains will just go mad. So they don't know which signal belongs where. So this is why we said we want to have a physical data line. And of course, we know the problems that it entails, in particular when it comes to the electronic contacts. We know that the data contacts in the DAC will most probably the most tricky factor when it comes to the availability of data. Mechanically things work, also pneumatically things work. It's not a problem, but the data line is the biggest failure source of failure. If you have a look at the coupling, there are 3 different approaches in this regard, and which will also then be tested in DAC for Europe in practice. First of all, we have a look at a pure data line via single per Ethernet technology. Then we have a look at a power line, meaning that we use the power line to communicate data, transport data, which means that would have the advantage that we don't have data contacts, and that could thus eliminate a source of failure. And the third thing that we're looking at is close area radio, so that the distance, the millimeters between the different coupling heads are not physically coupled, but actually data is transmitted via an antenna, so near-field technologies. So these are the 3 possibilities. Decision has not been made. It will have to be made in the very foreseeable future, but we need more input from the tests. Thank you very much. This short online seminar already answers the questions of VPI Austria, isn't it? Yes, I think the questions are answered. And we know the wagons, etc. And the biggest discussion is about how do I provide for a stable data and data connection and mechanical connection. So different lines, one line, and this was very beautifully answered in that answer. Thank you very much. Okay, talking about data, we also talk about electronic communication and transmission, and of course, when it comes to hazardous or dangerous goods, that's a very relevant factor. Question from VPI. Yeah, what is the X zone appropriateness? And then also, does a wagon with a DAC have any effect on the suitability for X zones? Well, all electronic components, and that's very clear, all electronic components that we have on the wagons, on the train, etc., have to be suitable for explosion zones, for X zones. So they have to be explosion proof. And it's also part of the specification for these hazardous or dangerous goods wagons, X zone 81. And this is not only a technical specification, but there also have to be operational rules which say that before you enter these zones, all voltage has to be shut down on a train, and it has to be made sure that it is shut down so that you can't go into such zones with voltage applied. Well, this is actually the icing of the cake when it comes to technological things. But the thing is acceptance. The VDV and us have been thinking about this because we're talking about several hundreds of thousands of wagons which look different than they looked in the beginning. I mean, something will be added they did not get a certification for example. Question, what is being done in order to adapt the EU rules in such a way that instead of individual certification by every individual authority, we will have, for example, a conformity declaration, for example, by the wagon keeper, and that this will be sufficient? This is only a partial aspect of it. Yeah, but let me try and answer. Now, let me go as far as saying, when it comes to the legal requirements, nothing will be changed. We have an implementation order from 2008. Articles 14 and 16 in particular are the legal basis on which you can do this conversion or the implementation. Of course, what you want to avoid is a requirement of a new certification. So you have to come up with a generic process which makes sure that the existing wagons can be put on track without a recertification. And we are working at this. What do you need as a basis? What do you need as the basis for doing this and achieving this? We have a new working group in EDTP, working group number 8, including the industry, dealing with this very topic. What we're trying to do is to create a sort of database and to sort of cluster the existing wagon parks. You know, I mean, you have thousands of the same time with the same structure, with the same equipment set up, etc. And you have proof for them. You have certification, and you have different you have drawings, etc., what have you. And all of this still exists in the archives of our industry. So if everyone opens their drawers and make their data, their information publicly available or widely available, so if we act shoulder to shoulder, we will certainly be able to create a basis of reliable data on the basis of which a holder, for example, then, or an ECM can assess their wagon park and say, okay, the 5,000 or 20,000 wagons I have are of type X. And here we have the proof, or we have saturation. We're talking about the difference only, the delta. So the compression forces coming in via the sides, for example. So the operational safety of a DAC certified wagon has to be generic, and it has to be cross-industry. But the wagon itself, of course, has to have the required stability. And if we all work at this shoulder to shoulder and make all our information available, and that's also a personal appeal, mind you, to the entire sector. If we do this, we can make it, and then it will become possible that the wagons that are out there, the 100,000 of wagons that are out there, can be converted or retrofitted without additional certification processes, and then put them back on track on the basis of the data that we have. So a big thank you to the head of WP8. So if we don't manage to do this, if we don't manage to do a pre-assessment on a generic basis, we will no longer be able to do this if we have some 400,000 certification applications. Well, yes, and it's also relevant for the producers who had been building these wagons, pressure tests, etc. We need all this data in order to be able to do this. Thank you very much. So we are nearly on schedule, fighting our way through the questions of the technical cluster. So a big thank you to all those who put up a question, and we now change over to the next item on the agenda. So without any further ado, we will go right into this. So please stay tuned in.
Now, during the break, we are going to take care of cleaning the microphones, and as we do so, I'd like to introduce the next block. It's about migration. We all agree that it's going to take a long time before migration will be over, because it needs to be done at a European level. It needs to take care of all sorts of operational limitations and requirements. And this is exactly what we're going to talk about with the experts that I would like to welcome on the panel. Now, the keynote speech will be given by Dr. Christian Kuhn. Dr. Kuhn worked as an advisor to EDTP. He has a solid background, in all things rail, and he's going to share some of his knowledge with us. After his speech, I would like to ask Stefan Leuf from Rail Cargo Austria to the panel. He is also very much involved in the project. And I'd also like to invite Andreas Lipka from DB Cargo, Head of Migration of DAC at DB Cargo. Now, we will proceed the same way as before. We will first listen to the keynote speech and then try and answer the questions that we've received from the audience. Christian Kuhn, you have the floor. Take it away. Thank you very much, Mr. Lavrens, for this kind introduction and for giving me the opportunity to say a few words on migration issues, DAC migration. So happy to do that in the context of my short speech. Now, I was asked to do the introduction to the upcoming panel. Migration within just 10 minutes. Now, that's not exactly easy. I hope I will try and do within 10 minutes. Now, let me tell you something up front, and this goes for me and my colleagues. We have not fully, validated the concept, the migration concept. Let me tell you this up front because I want to tone down your expectations a little bit. What I'm going to do is give you the preliminary result, which was worked out together with a lot of stakeholders, together with you, with them sector representatives, with a number of railway operators, with a lot of wagon keepers. And as we speak, We are trying to unite all the relevant organizations and associations to establish a broad base of information for the benefit of all of you, because we want to include all of you, or as many of you as possible. That's not easy, but nevertheless, I would like to tell you that, even last December, we did a half-day workshop where we discussed, migration issues from the wagon keepers' points of view. What are, the problems that they are seeing, and what can we offer as consultants? The next event of this kind is planned for this year with the Network of European Railway Operators on the 13th of January. So for all of those of you who are a member of this organization already, and for those of you who want to become members, feel free to get in touch with us, make your voice heard, please contribute your views. And so please bear that in mind when you listen to what I'm going to share with you from the current status of our work, which is not a final result yet. Now, we've already spoken about it, and it's been mentioned before that for a number of good reasons, we've decided to use the Scharfenberg design as the basic design for the DAC. It's not going to be downward compatible. That's important to say. It's not going to be downward compatible with the screw coupler. Now, the reasons have been mentioned, and they're easy to understand, I believe. But, this comes with a lot of issues when it comes to migration, because we all know that we're looking at the life cycle of freight wagons of up to 50 years, and that's the reality in the sector. You know that there is the big challenge that a big share of the fleet is no longer compatible with the new technical standard. And if so, we have to make sure that it happens in a way so that, our customers are not adversely affected by this changeover, by this migration. And this is exactly the challenge that we tackled in the context of the working group. Now, the bottom picture is a hybrid coupling for engines, for locomotives. And let me also tell you that without equipping a high number of locomotives with a hybrid coupling, it's not going to be possible to do the migration. We need sufficient flexibility, and this is why the traction units need to be capable to accommodate both, the screw coupler and the new DAC coupling. Are there other possibilities to bring together DAC couplers and screw couplers? Well, it can be done by so-called adapter wagons, which are already being used. You would have so-called adapter wagons which have one type of coupling on one side and the other type of coupling on the other side. So that's a way that is certainly going to be have to be used whenever wagons cannot be converted, or whenever old, outdated, legacy shunting locomotives cannot be brought up to speed, cannot be upgraded anymore. Another way of combining DAC and the screw coupler is not envisaged, and this brings us to the key question, which is, given these technical conditions, can migration happen in the first place, and if so, how? Are there alternatives or solutions to begin with? Now, we've decided to tackle this topic in a very comprehensive fashion. Nevertheless, I will try and summarize the key findings on a number of charts, which are pretty busy, and I had to simplify things a little bit. So please bear with me if I have to, do some simplification as I try to answer your questions. We know that, the real-life situation is much more complex than the graph that you can see on the slide. But nevertheless, I'm using this by way of example. There's, of course, 25,000 other versions in real life, but then, I need you to bear with me that I couldn't have, presented 25,000 charts. So this is a simplified view of typical production systems. And I would like to use them, as examples for different, solutions, hybrid solutions. So let's start with block trains at the top of the chart. block trains which more often than not they are put together, in a pretty simple way. And in an ideal world, you would always have the same wagons moving from position A to B. That's a pretty simple, scenario for migration because, these kind of carriage sets can easily be retrofitted within a matter of a couple of weeks in the workshops. And, all you'd have to do is replace the screw coupler with the DAC. And that wouldn't, require a highly complex migration project to be done. Now, the additional question that comes up is, what about the two endpoints of such a block train? Will it be possible to accommodate mixed operations at the endpoints? Well, that's certainly a question of the facility layout. What does the combined traffic terminal look like? What do the sidings look like? Will the carriage set, will it have to be shunted? Yes or no? Will it have been taken apart? Yes or no? Now, looking at individual cases, the following scenarios comes up. We have looked at a number of individual cases, which we will keep discussing with a number of stakeholders, and the answer is always, well, it depends. There will be scenarios where things will be pretty straightforward, but there will also be more complicated cases. And, this is what we cannot answer for each and every individual use case. We want to come up with examples. However, it's important to note that certain hybrid variants between screw couplers and DACs are certainly possible within a block train. As train drivers, it's not really a big problem. You don't really have to care whether or not you are, putting together your wagons with screw couplers or DACs. There will be a transition period where you will see both versions. So theoretically speaking, if you have sufficient adapter wagons, it's possible to combine or to put together block trains with the wagons which have both screw couplers and DACs. Of course, train utilization will be less good because the adapter wagons, are only used as links and cannot be used for transporting cargo. Now, when it comes to the customer sidings, this is where it becomes more complex, where you have to move individual wagons or wagon groups, and, where wagons from one train system will have to be moved to a customer siding and be integrated in a completely different block train. This is when things will start becoming really difficult and complex in terms of compatibility. For the time being, we assume that mixed operations will be manageable, with a certain share of capacity losses. Fairness dictates to say that. There will be critical cases where mixed operations will simply not be possible. But again, you will have to focus on the individual cases at hand. Now, when it comes to a single wagon load traffic and, where you have trains going through nodes and have to be shunted, between two long-distance trains. Of course, there's other ways of presenting these kind of networks, but the same question that you have to answer all the time is that you will have to, pool wagons from different origins for different purposes. Whether you want to do that, in large-scale shunting stations or smaller-scale stations, sooner or later, you will see that mixed operations with two coupling systems in the systems like that will just not be possible. Now, we could spend hours on end discussing this question, mixed schemes, but we just don't have enough time for that. And also, we'd lose lots of our audience, I guess. That's why I'd like to point out two things. We did a simulation based on the Munich Nord shunting station. It's available online, and there you can read up on it. And the statement derived from there is that mixed operations will only be possible with a relatively small number of wagons with a DAC and a large number of screw coupler, or vice versa. So it's possible, even though capacity losses will have to be accepted. But, it's not okay to have a 60-40 ratio also. And it won't be possible in smaller scale shunting stations. Well, that's where it's not going to work. And that's a reality that we have to face up to with all the implications that come with it. Also, when you look at the preliminary legs, the main leg, the subsequent legs of a journey, even more difficult here, even though, mixed operations may be possible or conceivable for an interim stage. We're currently trying to quantify, the ton kilometers. We are trying to find out, what's the amount of ton kilometers maneuvered or operated by mixed regimes and homogeneous regimes, and what about the exchange between the different systems, and how much of a loss to flexibility would be exerted by the migration. And that's why I would like to take a look at the core network for a moment. A core network not only for certain member states, but for basically all of Europe. So, what's the size of a core network composed of single wagons and adjacent systems, block trains, where empty wagon return is handled via the system, and how big is the system where you have neatly separable wagon fleets or wagon groups where you can adopt a case-by-case migration approach. Even there, we would like for migration to go ahead as quickly as possible, but it would be easier, though, still. Now, this is, the findings we've derived from the discussions we've had with a lot of experts and based on the tests that we've done. What are the limiting factors in a shunting station? Well, first, the performance level of the hump. If you have a lot of, adapter wagons, you have to interrupt, your operations all the time because you have to insert the right kind of adapter wagons. And that's why the, flow of operations would be impeded. Another scenario would be to try and form trains according to one type or the other. Then the limiting factor would be the number of directional tracks, because for each and every destination you'd need to have 2 tracks, where you need only one now. And the shunting stations in Europe, not only in Germany, are pretty busy, and that's why, such a concept will fail, because the shunting station capacity is just not good enough. So, everything that is on the periphery of the core network needs to be migrated so as to make sure that mixed operations is not happening. That's a big challenge. We know that, and I must admit that so far we have only identified one way forward, which is based on the technical solutions. We believe that the system migration will have to take place simultaneously within the core network. In the other network parts, which can be separated, doesn't have to happen that way, because that would be an unnecessary effort. And on the next chart, what I've tried to is to show you how this could work in theoretical terms. I tried to use only one chart. Usually you'd need 6 or 7 charts, so this has to be a simplified version, and I can only invite you to join our efforts and work out in greater detail how this could work. And yet another solution might be, for someone of you to come up with completely new ideas. Now, simultaneous migration. This is what the center bar is all about. How could this work? So there will certainly be a preliminary period where migration will start based on block trains, based on wagon groups. Our SBB cargo colleagues are already doing that quite successfully. So, this is the period of time where the screw coupler wagons would be removed Each carriage set is represented by 3 freight wagons, and they would be migrated within one step. And these wagons would be equipped with DAC level 3, 4, 5, you name it. And this means that these wagons, could start operations with all the required components. Now, we cannot give you any accurate figures. Stefan, you mentioned 450,000 freight wagons. I cannot tell you how many of these wagons can be migrated that way. However, based on the preliminary figures that we've received from railway operators and wagon keepers, we're pretty certain that this strategy will allow us to migrate a 6-digit figure of wagons, even though a 6-digit figure of wagons will, remain in the core network. So what would happen in the core network? Well, let me first tell you that over a short period of time, several hundreds of thousands of wagons need to be migrated. And it doesn't take a lot of analysis, to understand that the existing freight wagons, given the the preliminary legs and subsequent legs and the upfront effort, etc., that's not going to be a quick fix. It's going to take several months, and this would mean that freight traffic would be paralyzed for months. And because of the trade unions and their strikes, we know that we can do with a system standstill which only lasts a couple of days, but if this lasts several weeks, that's certainly not a good prospect for the country. Now, here's some good news. We've tried to find out what needs to be done so that the conversion from the screw coupler to the automatic coupler, and I'm not talking about the digital automatic coupler, can happen within a short period of time, even outside the workshops, without involving the workshops. And what comes to mind is a design feature of the selected DAC, which was not mentioned before. But you need to know that there is an internal package. It's the the tension spring and the outer package, which is the coupling head, and there's a pin in between. And this can be found below, underneath the freight wagon. If you want to take a look at that, you have to lift the freight wagon to install the old, suspension struts. And, if the wagon comes with a bogie, this can only be done in a workshop. Otherwise, you cannot, assemble and disassemble the suspension strut. Now, the good thing is that both the dimensions and the connection points between the spring package and the rest of the coupling head is such that the new spring solutions can be installed, and the new pin can also be inserted, and that's a key feature that we've looked at. In the workshops in Mannheim, for example, we've tried it out there, so it's possible to do it. So this will be key in making the migration a success. So, the wagons which are allocated to the core network will be equipped with everything up front, with the cables, with the other components required for digitization, so that, you've got the DAC inside, and all that remains to be fitted is the side buffers and the coupling. This will allow us to make sure that we will only have to remove the side buffers, attach the prefabricated components and the coupling head. And we believe this can be done, in the field, in a real-life scenario, in the train formation yard. You can do it, on larger customer sidings or wherever it makes sense to have as few empty wagons as possible and to do it quickly. First, time estimates are available. I don't want to bore you with figures, and more work needs to be done, but we believe this will be a key building block in making the migration a success. Let me also tell you that for sheer reasons of time, we will have to be happy with DAC too. Putting into practice electrical components within a matter of days, it's not going to be feasible. This would have to happen, in a second step, based on the mechanically modified wagons. But we believe that speed matters, and whenever you can speed up things, that's an advantage. So that's going to be a key element to our strategy. We believe it can work. And the final point, in order not to go on for too long, so another idea that was worked out in our workshops was the formation of temporary wagon groups. What does this mean? Well, you would take, two freight wagons, equip them with the DAC, and leave the, conventional screw coupler, the other two endpoints. We will do that before the conversion point or migration point, which means that these two wagons perform as one unit. And if you take a look at the traffic statistics, you will see that the size of the consignment is larger than one freight wagon. Now, I'm not going to give you too optimistic figures, but in practice, this means that for some time, these, wagon couples will have to be used. In terms of train formation, they qualify as, screw couplers. And once the main migration comes up, when traffic has to be reduced for some time, all we do is turn these couples around, and they don't need to be empty. The screw coupler moves inside, and the DAC moves outside. So for train operational purposes, these couples will be maintained for some time. And, it's perfectly possible for them to be used as you would use a DAC wagon without having to go to the workshop or without making any mechanical changes. That's the second point, which we believe will help us make sure that the number of wagons still available during migration is kept at an adequate level. Now, I don't want to disclose the fact that this approach will require a huge effort on the part of the sector participants, especially when it comes to the coordination between, different companies which otherwise, operate as competitors. But, if you want to have that solution as a sector, we will have to go down this road and, allow for this big bang to happen. It will be a big bang, and we have to make it work one way or the other. By the way, that's the approach that the Japanese adopted back in the 1920s when they introduced the mechanical coupling. They did it within one weekend. We won't be able to do that, but let's nevertheless be, sufficiently ambitious to do it in a short period of time, because this will also do for our customers, convincing them, that it's a good thing to be done, even it's going to be painful for a short period of time. And, afterwards, these wagons, would be disassembled again, the couples rather. Well, that's it, in terms of what's been happening at the level of the workshops. And I hope to have given you an idea about what we have done, and I'm looking forward to the discussion. Thank you very much.
Vielen, vielen Dank, Christian.
Well, thank you very much, Christian Kuhn. Well, it's quite remarkable how you can densify sort of 80 slides and get the message across. Thank you very much for that. Now we go into the discussion. I'd like to ask my colleagues to join us. We have about 45 minutes, and we'll try to work through the questions as well as possible. So let me start with a very easy to answer question on the uses of the DAC. On the quantities, Mr. Fair, are you representing the Alliance for the Rail? Now, as we know approximately how many couplers we need, how much will it take until we have sufficient couplers? How long will it take until they have been produced? Especially with an eye to the chip bottleneck, might it even be produced in the European Union? Thank you very much for the question. Well, of course, difficult to say, because we have an estimate on how many wagons would have to be retrofitted, but there's a big ask. Please take part in the discussions. Please take part in the questionnaires, etc. So because it will give us a bit of basis on saying how many couplers will be needed. Because it depends on the scenario, we are developing a rough concept, but nevertheless, we cannot say when we would need how many couplers. We will have to have a first concept on this to give first assessments, but we will not be able to tell as from where we stand today. Certainly, production capacities will have to be adjusted. They also have to be, and I think it will not be possible to deliver just in time. We will have to warehouse a certain quantity and produce certain buffer capacity so that we can make sure that the required capacities are available in line with the migration scenario. Stefan, let me take the microphone. Questions on operational migration, just use them in one go. We got many different questions on mixed traffic, block train operation, etc. Perhaps we can have the first question on what should come first, what the sequence should be. Let me make this very brief. Dr. Kuhn just said that when it comes to block train operation, for example, retrofitting or conversion might be easier up front. What happens with defective trains? They have to be transported somewhere, get to the repair yard or to the workshop. We discussed the possibility, and of course it happens. It's part of daily operations, isn't it? And it's also a question that we got several times. Christian Kuhn gave some answers to that when he talked about the car wagon load. So this big bundle of individual wagons, traction systems, etc. Now, as a picture is more telling than 1,000 words, I'd like to show you one of our backup slides, slide number 2. Thank you. Christian Kuhn already mentioned it. So we're casting a short glimpse into our workshop. Currently, we are looking at 9 different migration scenarios. And if someone asks us, what is your migration strategy, for example, when it comes to the transport of defective wagons, the answer is there is no such thing as the migration strategy. Perhaps for one big RU, there are 3 different strategies. So it always depends on what type of operational traffic we're talking about. The market is as diverse as we know. We have one track siding which might be used once per week. We have company sidings, corporate sidings, big ones, which are used every day, etc., etc. So there is no one-size-fits-all strategy. But when it comes to the intermeshed core network, we need a very good answer, because here this also includes the defective wagons. And, no matter as to whether we're talking about retrofitted wagons or screw coupling wagons that are still included, while most of the wagons have already been retrofitted, they must be embedded. But this also means that we have to know what type of traffic we're talking about. We have to know what type of cars, of wagons, etc. we're talking about. And so, please, appeal again, please take part in the EDDP, please take part in the working groups. I mean, it's fine if you come there and just sit and listen, but it would be even better if you would participate actively. We have developed models. I mean, we could go deeper into this, but with an eye to time, we will try to answer as many questions as possible, and we can then dig deeper in one of the EDDP workshops. Next one's actually coming around quite soon. Okay. I think we do have to summarize this. So far, we had always assumed that over the course of several years, step by steps, doing retrofitting in workshops, we feed that into the traffic step by step. And now someone asked about parallel operations during the migration phase. So, but it's getting clearer and clearer and more obvious when it comes to parallel operation. There's not very much potential for parallel operations, is there? I tried to be very clear about this. A real parallel operations will not happen. Of course, a small number of defective wagons in different locations can be included, and an RU which migrates to DAC will certainly most probably start with an area or region where a workshop is easily available or readily available. And apart from that, you need adapters. The idea that you might transport a defective wagon across Europe and to get it to some workshop somewhere, you can forget about this. You would have to get it to the closest workshop. So, but this is something you do today, in different shunting yards. So the question is, how many wagons can be retrofitted or converted without major problems? I think we already answered these questions in the technical part, but we have an additional question. Wagon capacities, new build, production capacities, how can all of this be included? And embedded lines, ProRail asked these questions. Andreas, can you answer these questions? Now, how long will it take if all the wagons available in the EU use their capacity for this purpose only? Well, the wagon producers, the factories producing the wagons, are part of the solution. What is important is that we use all available workshop facilities, and especially those close to home, so to speak. So we are looking for solutions. As Mr. Christian Kuhn already said, we are going close to the customers, close to the ports, to the siding, etc. So to use the retrofit capacities there and to keep the transport times low. Because, I mean, the retrofit itself is not a big thing, but the transport to the place where the retrofit or the conversion is being done. So if something is close to home, so to speak, it makes sense to use this. Question, what are the capacities in the field that we can use? I would always try to keep things as close to the customer as possible. Well, that's capacity, that's management, and the colleagues already mentioned that we will have to calculate how much we will need, in which countries, how many days will be required. We are not there yet, mind you, because the concept as such has not been presented here. But, other things have to be borne in mind. What about operational rules? The VDV is asking that. It's on page 3, somewhere in the middle. The use of the retrofitted cars of the rolling stock is used on a European scale. How do you make sure that the required operational rules are harmonized on a European scale, such as the automatic brake test? Well, I think you have to differentiate between different things. Technical solution. The technical solution used for doing, for example, take the automatic brake test, have to be harmonized, of course, and has to be standardized. The European rules are very much national. You can criticize this, but that's the way it is. So if you have a standardized technology and proof has been provided, we still have a situation that when it comes to the national rules, AOBs in Germany, for example, and different rules in different countries, this has to be introduced into those rules. So the different associations, such as VDV in Germany, for example, have then the task to further develop the operational instructions and operational rules on the basis of which the individual operators then have to implement them in their own responsibility. I'm quite confident, actually, that in particular in Germany and in many neighboring countries, we are sufficiently innovative to do this. Because once we have a technical solution for an automatic test, brake test, I'm sure that every RU will use this. And what about health and safety at the workplace? What about problems there? Health and safety at the workplace. Now, in operations, this is particularly relevant when it comes to the engine. We will not have a solution without a hybrid coupling, because in a very short period of time, a lot of conversion and retrofitting has to be done. The big advantage of the hybrid coupler for the engine is that, yes, you can switch over fast, you can react fast to different traffic situations, but it's heavier and the burn rectangle is being limited. So that's an issue. So we believe that without a hybrid coupling with the engine, things will not work. So in the run-up to the migration, till day X, when the migration will take place, the engines will also have to refit it to such a degree that at day X, you can not only retrofit fast, but that also the engine can be provided quickly for DAC operation. The run-up to hybrid couplings, preconditions for hybrid couplings. There was another question on that. Yes, there was a question on hybrid coupling. What is the migration period for hybrid coupling for the engines? What are the advantages and disadvantages, such as their weight, and what about financing? Now, on migration, we already mentioned it. Up until point in time of the migration, point in time X, wagons are converted. You build pairs, for example, but also the engine has to be prepared so that the migration can be done at the pre-specified date. So advantages, disadvantages have already been answered. The weight, of course, the limitation to the burn rectangle. And the costs are higher than for standard automatic coupling. But basically, it is a basic requirement or the enabler, the key enabler for the migration being possible at all. Then from Austria. Now, how do you get information to the people doing the actual work? I think this is also a question on health and safety at the workplace. How do you make sure that the operational instructions will be provided to the people who do the actual work? What are the additional measures that are planned here? I think this is also part of the basic conditions, and you see this with the demonstrator. Who has to be trained when and where so that they will be able to handle a DAC in the first step? So we are developing some basic training material. This is the EDTP, but every country, every infrastructure operator, etc., is responsible to train their own people. So we can provide some basic information material. You can define who is being trained when. But in the last analysis, it's up to the different partners and stakeholders to do this training, to train the right people with the right material. So this is all very national. So everyone has to come up with their own solutions, but on the basis of a general package. Yes, and we also very well aware of the fact that we will need different job profiles. This has also been discussed also in the workshops when it comes to conversion, retrofit, for example. We will need different job profiles. Let me take that. Yes, also it's true for workshops as well. I compare this to the car repair workshop. You had a mechanic in the past, and in the next few years, they become a mechatronic, right? So when it comes to freight wagons and the workshops, you will no longer need mechanical knowledge only, for example, but also electronic knowledge, etc. So this is also one of the reasons why we believe that you have to split up migration in two parts. One part is the mechanical part, this is the AC, so to say, and then add the electronic components step by step. So this also gives you more time for the workshops and the people working there to get their knowledge up to speed. So I think we got to include the workshops. I think this is a very clear message, isn't it? The migration periods. When do we have to do this? First the engines and then the wagons, the cars. What's the period of a big bang? When will we have the first engines? Well, we don't know yet, actually, to be honest. Now, this is something we're working on at the moment, so that we really know when what has to start, when which preparations has to start, that on the defined start date, the day X, as I always call it, things will be done so that in a very short time, well, 2 days would be unrealistic, but so the actual migration can be implemented in a very short period of time. Now, the project itself will be developing a first implementation plan. But then, things will have to be broken down very specifically and will have to be adjusted very specifically by the different RUs, wagon holders, etc. But again, we'll try to come up with a general script. Well, the retrofitting of the engines, and I think that's obvious to anybody, has to take place before we retrofit the wagons, because otherwise you cannot draw it. Would you please give me the backup slide number 7? There will also not be the one engine coupling. Christian already said it. We will probably see a lot with many engines, which will look a bit like this. So we see the automatic coupling in Switzerland, which also is a screw coupling. It's a hybrid coupler. But we also have rolling stock, which just doesn't have the mounting bay. Then we have rolling stock with the heavy SA3 coupling. It's not our favorite solutions, but we could do this. They don't need the mounting bay. They use the space before that. We don't have this for the DAC, but this has to be translated, so to speak. And then, very simply, in a very simplified fashion, it's not what we favor, but again, we have the siding operator that might have a shunting locomotive which is 30 years old, and they use this engine 3 times a week. They will not retrofit this old engine with a hybrid coupling. They need something like on the right-hand side that he can use. And these things have to be developed in the EDTP, and they have to be there, they have to be finished before we start retrofitting or conversion. So the engine challenge is enormous. We are facing up to this challenge. We have to, otherwise we will get nowhere. But I mean, the scope is well beyond the simple concept of a DAC. It's much more complex. And also, we need more people that chime in, that make a contribution, that bring in their good ideas. Okay, we have additional questions on the hybrid coupling from NEE. They have a question on hybrid coupling and the migration period. Question with regard to the workshop, what migration period, because I had already asked one question. Yeah, the question's already answered. And then what about the VCI? So the VCI is asking about the stop blocks and the infrastructure. I might use this. Can engines be used for both coupling types? I think we already answered this. And then there is a question of mixed operation and infrastructure as to whether there is a transition period for stop blocks that can be used for both couplings or couplers. When it comes to the stop blocks, with the DAC, that would be our favorite model. We have a Scharfenberg coupling head, which is already being used in passenger traffic in many parts of Europe. So there are stop blocks with faces that are that can be used for Scharfenberg couplings. We also have stop blocks with buffers for both. For example, at the center you have the Scharfenberg block, for example. Still, nevertheless, you have to give it some thought, because theoretically speaking, the infrastructure is not primarily interested in a DAC happening. And then we get to them and we say, hey guys, you need new stop blocks. And then they might be saying, well, we don't. Or in some countries it might be necessary, or there might be regulations that say so in some European countries. So it might not be relevant for some. But DAC, affects so many areas in rail traffic that the seemingly simple topic of stop blocks will be hitting us sooner or later. And we have to face up to that. Because if you want the infrastructure operators as players, and they will also benefit from that. We heard this from Armin Günther. Benefits are considerable when it comes to infrastructure, because we are the enabler for several big infrastructure projects, ITCS level 3, for example. If you want to win them, we must not leave them alone with their stop blocks. How many stop blocks do we need? Oh, good question. I can give you an answer for Germany, 14,000. Some of them already are available in this hybrid version. And what does a replacement of a stop block costs with the crane and so on and so forth? So if you could just not retrofit this, if you were to replace them, 30,000 euros for one stop block, all included, times 14,000 gives us 3-digit millions for stop blocks only. There's not one single coupling. You might say, well, I don't need that. But at the end of the day, you at least have to look into this question. If the answer is, I don't need that, that's fine. Okay. And of course you have to have an answer to that, no doubt about this. But to take an existing stop block and to screw something on top of that, it doesn't cost you 30,000 euros, I mean, I've worked with Deutsche Bahn and others. So, and also, let me remind you of one thing. A Scharfenberg coupling are being used all over Germany in passenger trains. We already have lots and lots of passenger trains, tube trains, etc., using a Scharfenberg coupling without any side buffer. And it seems to work. So I don't think that the stop block should keep us awake at night. We have to have an answer, but it shouldn't keep us awake at night. Okay. Let's come up with an additional questions from VCI, who are having questions on the sidings, the infrastructure, etc.
Happy to take that question. That's particularly relevant for the VCI members, but also for other industries. And I've tried to respond to that question in my speech. And I want to say again, it depends on the individual case in question. Each and every factory or railway or port factory with a lot of shunting activities will come with a huge potential to benefit from the DAC. Especially in shunting operations, the advantages are clear to see. There will be cases, and we saw that in Linz in Austria, where we looked at very small customer sidings where this migration phase would lead to all sorts of troubles. Imagine the following situation. Two tank farms adjacent to one another, two loading points on the same track where you can fit in 5 cars. Now, if you look at that, it can lead to all sorts of difficulties. Of course, these are very specific infrastructure-related cases to which you have to find solutions. And, ultimately, we are going to have to deal with these individual cases. There won't be a one-size-fits-all solution all over Europe. Once you've worked out the high-level concept, you will have to try and drill it deeper and break it down what it means for the individual infrastructure operators to obtain their feedback, where the trouble spots are in their countries, where are the biggest problems to be expected. It won't work any other way. So, these are all arguments to make sure that the migration phase is kept as short as possible. If we can avoid mixed operations, even better. Of course, there will have to be upfront investment, but then, that's the way it works, and that's why we need proper funding, which is something we still have to work out. So, what can we learn from that? We can learn that stop blocks shouldn't stand in our way. Rather, we should focus more on effectively communicating about costs, especially for the smaller scale participants. Now, I want to assure you, get me right, the migration period has to be short for each respective network. The core wagon load system that we've already talked about will be the big challenge, because here we want to avoid restrictions to operations to the extent possible. But this applies to any other network too, wherever train movements take place. This is where we need to make sure that migration happens very quickly. And if we were to put a timeline to the European map, I think it's fair to say that, looking at the whole exercise, upfront investments, electrical equipping, etc., we will still be talking about, a multi-year perspective. Individual networks and the interfaces, this is where migration will happen quickly. But the total migration, will take several years. We need to be very clear about that. Migration will take years. Migrating individual networks has to be has to happen quickly, but the whole thing will take very long. Now, we've received more questions on, qualification, converting wagons, etc. Perhaps I can put this question to you by way of conclusion. Well, earlier we saw 3 different migration routes, and looking at that, it will have to be necessary to touch, wagons twice. You may start with the coupled strategy, where you convert one coupling first and the second one later on. This can only be a first step, because ultimately you will have to convert all couplings. And, this will involve operators of trailer wagons. So whatever can be done in workshops has to be done there. We have to try and prepare things to the extent possible to only have a box stop like changeover of the couplings. This is what we want to achieve. We want to do these conversions as closely to the customer as possible. Now, when it comes to the digital components, I have the idea that they would be fitted during, scheduled workshop operations. So we are going to use scheduled maintenance and service works to do some part of the conversion effort. But nevertheless, after the actual conversion, some more time will be required to finish the work. Before I hand over to Malte, who will deliver the concluding remarks, even though we could go on talking for a long, long time. But I think that, everybody listening to us here and the viewers behind their screens, I guess you will all agree that we need to make this a success, make the migration a success. What we've heard from the gentlemen at the panel is not their personal opinions. This is what they've said is echoed by all the stakeholders out there, and so far no one has come up with a better idea, how the migration can be handled in a better way. And what remains is the fact that the migration will be a huge effort, which may or may not take in 2025 or 2026. And, it will take, 20, it's not going to be a solution to have a wagon in the workshop and convert it within a matter of 20 hours or so. This is not how it's going to work. It's similar to the vaccination effort that's currently underway. Most likely, we're going to have to adopt an approach as, demonstrated on the panel here. So we should all be prepared for a scenario that's going to take a pretty long time with some adverse effects for everybody involved. Well, unless the migration works, DAC cannot be introduced. Simple as that. After the lunch break, we are going to talk about another topic without which we cannot hope to make any progress either, funding. Because without adequate funding, we are not going to make any progress. That's a fact. And we're going to look into funding questions after the lunch break. I'd now like to invite all of you to a 30-minute break, both the participants on site and the same goes for you listening to us on your screens. Let's try and be on time. It's 12:20 now, so let's continue at 10 to 1. 10 to 1, this is when we will continue, and the next block will be, on costs and benefits, and the fourth block will be on financing. So please stay tuned. We have interesting panelists, interesting presentations in store for you, so you can expect, a wealth of information, everything focusing on the introduction of the DAC. See you again at 12:50, 10 to 1. Bye-bye.